Let's start with a stop. Your velocity is zero. Position's just a measure of where you are. And if you never give it an acceleration, you're gonna stay parked in your little car.
Ever struggle trying to increase your speed? Keep your alignment in turns? Trying to get enough height in your jumps? If this looks like you, pay close attention to the screen. We're here to help. Keep calm and let the physicists handle it. In today's lesson, we'll be showing you the physics behind a PK turn, lame duck into a chaîné renversé. Stay tuned while we break it down. To begin with, the first movement of the phrase is a PK turn. Before the dancer even begins movement, her body is in static equilibrium.
Okay, good.
This means that the body is at rest and the forces acting on it are balanced. The resultant of these forces equals 0. That is, the vector sum of the forces adds to 0. To break down the PK turn, the first part of it is the plie. While the dancer is in a plie, it is changing the potential energy by applying force. In this case, the force would be momentum. The second part of the PK turn is a weight transfer into the passe position. This is where the inertia of the arms and legs come into play. The total inertia of the body is determined by adding the inertia of the arms and legs. Inertia is the resistance to motion, therefore it is based on the weight, length, and size of the body parts, and because of this, the more inertia you have, the slower you go. This is why the dancer starts with her arms open and closes them to create less inertia, which makes them rotate faster. The arms are in first position, which is in a ring shape, and the equation to find inertia within a ring is 2mr squared. The working leg is in a triangle position, so you would need to use 3 different inertia equations for the 3 separate parts of the leg, because no one's legs are perfectly skinny and are the same length and size throughout each part. For example, the torso is rotating around the supporting leg, so that leg has inertia of... What the fuck does that mean?
Where are you?
Take 97. For example, the torso is rotating around the supporting leg, so it has an inertia of 3/2 mr squared. Whatever that means. The body is rotating around a vertical axis on the supporting leg side of the body. The second movement in the phrase is a step across turn, otherwise known as a lame duck. As you can see, the leg rotates before the body. The leg rotates faster because it has less inertia. The right leg produces the torque. The weight shifts so that the center of gravity moves forward to be over the left leg. Once again, the dancer brings her arms in to create less inertia to rotate faster. Additionally, the arms move at the same time as the torso, not the legs, because you don't want to shift the center of gravity. The last movement in the phrase is a renversé. To get into the jump, the dancer executes a chaîné. To do the chaîné, the dancer once again brings her arms into the first position, making a ring. The inertia would be 2mr squared. The torso is like a solid cylinder rotating around a central vertical axis. Therefore, the inertia of the body would be 1/2 mr squared. The dancer chaînés in plie in order to gain momentum, which she does so by applying force into the ground with her muscle. The rotation and height of the jump is affected by the amount of muscle the person has and the amount of force the person applies. The ground force acting up against you ideally should be double your weight if you are applying your maximum weight force into the ground. The more muscle force you apply and the more you plie, the higher you will jump. If you do not have the proper prep for the movement, you will not be able to perform the move as well as you are supposed to. The second part of this movement is the actual jump. The arms go up into 5th position, still being in a ring, making the inertia 2mr squared. The working leg extends out to 2nd position. Making the leg like a long thin rod with rotational axis through the end with an inertia of 1/3 ml squared. Before the dancer lands, the body is in rotation around the axis of the supporting leg, making the inertia of the torso 3/2 mr squared. To land, the dancer brings the arms out into 2nd position, increasing the inertia to slow the body's rotation down. The longer the radius of the arms, the greater the inertia. The arms extended out in 2nd make a long, thin rod with rotation axis to the center of the body. The inertia of these arms is 1/12 ml squared. The center of gravity is over the front foot.
Bravo! You completed the phrase. But wait, there's more!
Throughout the whole phrase, the energy is constantly changing from potential to kinetic to rotational and ending again with the same potential energy. Well, there you go.
Well, there you go.
1, 2, 3.
Well, there you go.
Now you're on your way to being a professional dancer and physicist. With the memorization of these equations, now you'll be able to do 32 flatte turns on point.
Wow, good timing.
Do not have to do this if you are pregnant, nursing under the influence of alcohol, of drugs, or have just taken a Jovo stretch class. Side effects may include brain swelling, depression, never wanting to leave your bed, and severe cases of Netflix.
Perfect.
Can you understand
Perfect.
Yeah, so good. How do I end
I want to be said by car announcer.
This is a Manhattan bound fast local train. The next stop is 50.
I can't.
Prospect Park.
Stand clear.